Hello, Jaguar students. It's your friendly neighborhood math teacher, Mr. Allred, and we're here today to talk about our last mini lesson, Unit 10. We're going to talk about using area models to find compound probability. Okay. Before we begin, I just want to remind you of my quote of the week this week from our good friend Winston Churchill. He once said, "The optimist sees the opportunity in every difficulty, while the pessimist only sees difficulty in every opportunity." Try to take that to heart today as we work through this mini lesson. Sometimes it might be challenging and difficult for you, but if you see them as opportunities, rather as difficult, instead of difficult math problems, I think you might find light at the end of the tunnel. Here we are. Alas, alas, here we are. Okay. Over the course of this 3-day unit, we've talked about some key concepts. We've talked about simple events, the term probability and what it means. Those are some of the big words we talked about. Okay. Ed Pelzel is about to ask you if you know what those two words are, and then I'm going to tell you what they are. A simple event is when one event happens, like flipping one coin or rolling one die. Anytime you do that, you're operating under a simple event. Those are some of the easier things to find the probability of. We wrote it as a ratio. What is probability, you ask? That's what it is. It's a ratio that describes the chance that an event will happen. So we talked about ratios way back in Unit 5. See how this unit has brought all of that prior knowledge back to us down here in Unit 10. Okay. Probability is a ratio describing the chance an event will happen. Yesterday, we talked about tree diagrams. We drew those tree diagrams to talk about the probability of having 4 boys in a row when you have kids. We talked about the probability of getting 4 sixes in a row when you roll a dice. And that would be what you would use when you have more than 2 simple events happening. I would suggest you use a tree diagram when you have more than 2 simple events. Today, we'll talk about one other strategy you can use to find the probability of a compound event. When you have just 2 simple events, it might be wise to use an area model. Okay, this is only when you have 2 simple events happening when I suggest this. Okay, first example, I'm going to work through one example for you. I'm going to get you started on a second example, and then Ed Pelzel is going to close it out for you and do the rest for you there. Okay, here's an example for you. Let's say you have 2 buckets. Okay, in those buckets you have some marbles, and in bucket 1 you have 3 marbles. In fact, you have 1 red marble and 2 green marbles. I don't know about you, but I like to keep my marble buckets nice and separated, especially when I go back home late at night to play with my marbles. I like for my buckets to be nice and organized, just like these 2 buckets are. So in bucket 1, you have 1 red marble and 2 green marbles. In bucket 2, you actually have 4 different marbles. How about that? I know math class is so exciting. You have 1 red marble, 1 blue marble, 1 green marble, and 1 yellow marble. You might notice that I have lost my marbles. You can take that to mean whatever you want it to mean, but we're going to talk about using this area model to find probability. You might be like, whoa, Mr. Allred, we looked at something just like this in science class just last week when we talked about genetics. That's right. You talked about Punnett squares. And let me tell you a little secret. Science stole that from math. Math did it first. And here's what an area model looks like. We're going to draw a 3x4 rectangle. Okay, the reason we've drawn that 3x4 rectangle is because the left side of this rectangle lists the outcomes for bucket 1. 1 red marble and 2 green marbles. They're down the left side of this area model. See how I've drawn my rectangle? I gave it 3 rows. I gave it 4 columns because bucket 2 has 4 different marbles: a red, a blue, a green, and a yellow. Okay, what I'm going to do is I'm just going to match up a row with a column, and I'm going to list that particular outcome in that square of my rectangle. Okay, so if I picked up a red marble from bucket 1 and a red marble from bucket 2, I would list that as RR, some rest and relaxation there for you, doing math problems, just relaxing, all cool, shooting some b-ball outside the school. What am I talking about? That's right, I'm talking about area models. So you picked a red marble from bucket 1 and a red marble from bucket 2. Okay. You could also pick a red marble from bucket 2 and a green marble from bucket 1. That's right. That could totally happen. You could even pick just the same thing again, since there's 2 green marbles in bucket 1. You could pick a red one and a green one from those 2 different buckets. So far, I've listed 3 outcomes: picking up a red marble from bucket 2, and then a red or a green from bucket 1. It's possible I could pick up a blue and a red. It's possible I could pick up a blue and a green. It's possible I could pick up a blue and a green if I picked out one marble from each bucket. That's 3 more outcomes for you. It's possible I could pick up a green and a red. Possible I could pick up a green and a green. Possible I could pick up a green and a green. There's 3 more outcomes in that column. It's possible, very, very possible, that I could pick up a yellow and a red, a yellow and a green, or a yellow and a green. I'll give you a second to really take all that in because it's pretty marvelous. Take a sip of water real quick. Okay. So, in fact, there are 12 total outcomes. If you count them up, you can see what I mean. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 distinctly different things that could happen. Okay. We're going to talk about the probability of choosing the following combinations. We're actually going to get 1, 2, 3, 4, 5, 6, 7, 8 answers to this one math problem right here. Okay. If you look at your chart, there's only one way you could pick up 2 red marbles. That's this one column, this one square, right here. You could pick up 2 red marbles in only one way. You have a 1/12th chance of picking up 2 red marbles. Okay. If you count the red blues in any order, even if you pick up a blue and a red, that still counts. So you can pick up a blue and a red. You could pick up, just a blue and a red. That's the only thing you could do. There's only one way you could pick up a blue and a red. That's because there's only one red marble in one bucket and one blue marble in the other bucket. Okay. It's also possible you could pick up a red and a green if you count up the number of GRs or RGs. Miss Merch is yawning because she's super bored sitting here with me. There's 1, 2, 3 green reds or red greens. So there's a 3/12th chance. I don't know if you can simplify fractions, but you've been doing it since 3rd grade. That's the same thing as 1/4. You hanging in there, Miss Mertz? She said, yes, I am. She's ready to keep going. Okay. It's also possible you could pick up a red and a yellow. There's one way right there. There is only one way to do that. Okay. There's a 1 out of 12 possibility you could do that. Okay. There are some green reds. We actually already looked at that when we did RG. There's 3 of those. That's a 1/4 probability. There's a couple green blues. There's a blue-green right there and a blue-green right there. I don't know about you, but I don't see another one. There's a 2/12th chance that could happen. Same thing as 1/6. Okay. If you look for the green greens, there's only 2 of those as well. There's a 2/12th chance, a 1/6 chance that can happen. Look for the green yellows. Hey, what do you know? There's 2 of those as well. So there's a 1/6 chance that could happen. Okay. I know there was a lot of math that just happened, but all I did is I knew there was 12 total outcomes every time, and I just looked in my area model for the combinations I had already made and counted up the total number of each one. Okay. Okay, Jorge, got that? All right, cool. Look at number 2. It says you're going to play a game. It's going to be amazing. It's called Making Purple. The idea of this game is that you will spin both spinners. Here's spinner A and spinner B. And if you get blue and red, then you win the game because that makes purple. You only spin each spinner one time. Okay. What I have done is I have actually taken spinner A and I have made a 6-rowed rectangle with red, blue, red, green, red, yellow. That represents the 6 different colors on spinner A. I listed that down this side of the chart right here. On the other side of the area model, I knew there was a blue, a green, and a red. I listed that on that side of the chart. Okay. I want you to fill it out and figure out how many outcomes there are. That puzzle is going to ask you how many outcomes there are, and then it's going to ask you what the probability of making purple is. When you want to make purple, that means that you need to get a blue and a red, one from each spinner. In any order, you can get a red and then a blue, but as long as you get blue and red, you win. That puzzle is going to ask you for how many combinations there are, and then it's going to ask you what your final answer was. The truth was there were 18 total outcomes. 18 total outcomes. And when you come to my station later in the class period, we'll talk about what my final answer was and how I got it. Okay. And I'm going to ask you to work through these next 2 math problems, number 3 and number 4. They're on the right side of your paper before you come to me in my station. Thank you for watching. Have a great day. Make it a great day or not. The choice is yours. Thank you.